continue on with these fundamental trig identities. Up here. First of all, we're going to look at the reciprocal identities. Now we've kind of talked about these already. You know, sine is the same thing as 1 over cosecant. So of course cosecant is, guess what? 1 over sine. Okay. The cosine is 1 over the secant, whereas the secant is 1 over the cosine. Okay. And of course you got your tangent. Tangent, 1 over cotangent, cotangent, 1 over tangent. Okay. There's some quotient identities. Quotient identities that we've talked about. One of which was the tangent. So the tangent is defined as the sine over the cosine. And the cotangent, its quotient identity would be cosine over sine. Okay. You also have some Pythagorean identities. Okay. So your Pythagorean identity, sine squared theta plus cosine squared theta equals 1. Just a little bit of backdrop on that. If you remember from the unit circle approach, you remember how in your unit circle we had x squared plus y squared equals 1, right? On that unit circle, and x was our cosine value and y was our sine value. So the cosine of theta plus, and our y again was our sine value. Is that right? Now we actually write this cosine theta quantity squared is also written like that, cosine squared theta. Okay, and sine of theta quantity squared is sine squared theta. Okay, and they usually write it sine squared plus cosine squared theta is 1. Okay, so that's one little look at that from the unit circle anyways. And again, note that, let me erase this other stuff here. Come on. Not working. There we go. Okay, note that sine squared theta is the same as sine of theta quantity squared. So that's like your notation for that, right? So sine squared plus cosine squared theta equals 1. That's a really biggie. Okay, you gotta memorize that. 1 plus tangent squared is, in fact, let's do that. What is 1 plus tangent squared? Okay, what would it be equal to, considering that sine squared plus cosine squared equals 1, or using these quotient identities and things. So let's go to the side for a minute. 1 plus tangent squared. Well, tangent is sine over cosine, right? Sine over cosine. But it's really sine squared theta over cosine squared theta, right? Sine squared over cosine squared, because I'm using the power of a quotient property there, where that squared goes to both of those. Now this is 1 over 1. I want to get the same common denominator here, so I'm going to go ahead and multiply this by cosine squared, cosine squared. Okay, so you see how you now have cosine squared plus sine squared all on the top. Well, guess what cosine squared plus sine squared is? That's 1, right? We just talked about that. And on the bottom we got this cosine squared theta. Well, what is 1 over cosine? Since this thing is squared, right? 1 squared over cosine squared, that's the same thing. Well, that is secant squared. Secant theta squared. So back up to, what is 1 plus tangent squared theta? Guess what that is? That is secant squared theta. Okay, and it all stems from those properties, doesn't it? Okay, let me actually erase those again. Yes, worked this time. Okay, one more of those Pythagorean identities. 1 plus cotangent squared is the cosecant squared of theta. Okay? All right. Let's move on to another one here. Different problem. Let's use some of those identities. All right, so let theta be an acute angle such that cosine of theta equals 0.96. Find the sine of theta and the tangent of theta. Okay? Well, if you're going to use your trig identities to do this, and there's different ways to approach this, but we're going to practice it with using the trig identities. You say, well, I know, here's my money formula, right? Sine squared theta, write this over here, plus cosine squared theta equals 1. All right, I love this thing. Why would this be useful? Well, I have the cosine of theta already. So now I could solve for the sine of theta using this, right? Sine squared theta plus cosine of theta quantity squared. In other words, 0.96 quantity squared is 1, right? So subtract this 0.96 quantity squared, whatever that number is, from 1. And then sine squared theta equals whatever that number is. And then I'm going to square root, and I get the sine of theta is whatever that is. Let me grab my calculator just a minute. All right, looks like 0.96 squared is 0.922, so 1 minus that is 0.078. Now I got to take the square root of that 0.078. Looks like I get 0.28. Okay, 0.28. So the sine of theta is 0.28, right? And of course we could check that by saying, well, 0.28 squared plus 0.96 squared should be 1, right? But anyways, all we needed was the sine of theta, so we stop right there. We don't care what the angle is, but we do know the sine of that angle is 0.28. And then we say, hey, you know what? Tangent of theta, quotient identity, is sine over cosine, right? So we got sine 0.28 over 0.96. So whatever that is, there's my tangent. .929, 0.292, I'm sorry, 0.292 it looks like. 292. Okay, so there's our tangent of theta. And, move on here. Let's use some trig identities to transform one side of the equation into the other. So, like, let's say, and theta is you know, between 0 and 90. So we're going to verify. Verify by showing or taking one side of the equation, one side of the equation is equivalent to the other side. So we're going to verify again. And theta is between, let's go with 90 degrees greater than 0. So we got this acute angle for theta, okay? So let's do this first one. Let's take a cosine, let's take cosine secant. Secant theta equals 1. And you know, I typically work with my left-hand side, but you take the more complicated side, if you will, typically, which is your left-hand side, and you show that, you whittle it down, so you work this down until you get 1, all right? That's an algebraic proof here. So that's what we're going to do on this one. So you say, well, cosine, and I like to get everything in terms of cosine and sine, almost always, right? Most of the time. I love my cosine and sine, right? Don't tell my wife. Secant is 1 over cosine. And again, we're working this down. Hey, you see how you got cosine, multiply numerators, over multiply denominators. Cosine. Hey, what's that? Cosine over cosine? That's 1. That's what we were trying to show. That equal 1 this whole time, right? So there's a verification. Let's look at this second problem here. Let's do tangent squared theta equals 1 over theta minus 1. Okay, so if we're going to go ahead and verify by showing that one side of the equation is equivalent to the other, you know, you can use either side here. You know, maybe go with the right initially because that's, you know, it looks a little more complicated, and see if that'll simplify into the left. You notice on the right hand side, so we'll do that first. Notice this right hand side, you have 2 terms, right? So, and we need to make it into 1 term, that cotangent squared. So why don't we get a common denominator here first of all? So I'm going to multiply this by sine squared theta over sine squared theta, right? So I got 1 over sine squared theta minus sine squared over sine squared, which is 1 minus sine squared, all over that common denominator, sine squared theta, right? And then you're looking at this, you're like, okay, wait a minute, 1 minus sine squared, okay? Think about that Pythagorean identity that we had. You know, just go to the side for a minute and think, okay, that's sine squared theta plus cosine squared theta is 1. Hey, I could transform that into 1 minus sine squared theta. This is a very oft used identity for these verifications. You're like, hey, look at that. 1 minus sine squared theta is equivalent to cosine squared. That is what I'm going to plug in right there. Okay? So go ahead and do that. So you replace the 1 minus sine squared with cosine squared theta. You have this sine squared theta on the bottom, don't you? Don't mind, I'm going to erase this stuff here. Okay. All right. And then this is the same thing as, if maybe you want to think about it this way, the notation isn't cosine over sine, that is the cotangent. So this is cotangent squared theta, right? Cotangent theta quantity squared, which is cotangent squared theta. Check mark, right? Now, what if we actually wanted to do this? Let me extend the page a little bit. This same problem, but we wanted to work with the left-hand side, which we could. You say, well, let's transfer all this stuff into terms of sines and cosines. Right, so go ahead and say, well, that's cosine squared theta over sine squared theta, right? Because cosine over sine is your cotangent. And then you're looking at that, and I'm like, wait a minute, I got to break this up into 2 terms, right? I want to get to look like the right-hand side here. So what we're going to do is, and you notice the sine squared on the bottom is, and you got a sine squared on the bottom over there on the right-hand side. So you're like, well, let me see if I can make a replacement with that. So you once again go to the side and you say, well, isn't sine squared plus cosine squared equal to 1? Sure it is. What is cosine squared equal to? Well, that would be 1 minus sine squared, right? Because I'm subtracting sine squared both sides, right? Subtracting sine squared here, okay? So cosine squared is equal to 1 minus sine squared, right? So I replace that with 1 minus sine squared, okay? So now you say, well, this is our common denominator right here, both of those terms in that numerator. So I got 1 over sine squared theta minus that sine squared over sine squared, okay? Which is 1 over sine squared minus 1. Hey, look at that. That's equal to that right-hand side, isn't it? Okay, perfect.